So in this video, we're going to talk about another types of differential equation, a first order differential equation. Alright, in the previous lesson, we are talking about the first order differential equation, which involving separable variable, which the variable can be separated into the right hand side and left hand side, and we can integrate both sides easily. So, and this is the second type of first order differential equation, so which is namely as first order linear. First order linear differential equation. Alright, so first order linear equation can be written in the standard form. Alright, standard form means that it can be written in this form. As long as you can written in this form, then this is a first order linear differential equation, which is in the form of dy dx, px, a function in term of x, multiplied with y, and this is linear power of 1, so is equals to qx. Regarding of any function of x, okay, as long as you can written in this form, and this is the first order linear differential equation. For first order linear differential equation, we have to apply the integrating factor. All right, integrating factor. So we were integrating factor. There are many type of representation for integrating factor. For me, I'm going to using the Vx here. So integrating factor is defined to be the exponential integrate the px dx. You have to get the px after you have write the differential equation in the form of standard form. Okay, this is the standard form for first order linear differential equation. So why this is the one that we're going to apply. Okay, this for this type of differential equation. So this is the techniques that we need in order to solve this differential equation and getting the general solution or the particular solution. Alright, so there are some algorithm, there are certain steps that are fixed that you must follow. Alright, so I'm not going to explain all the steps here, but I will explain the step through the example. Alright, okay, let's look at the examples. Alright, let's start with this example. Okay, so once you look at this, you can see that this is something that can't be separated into two sides. Okay, no matter how you try. Okay, you can try. So if you can write dy dx, and this one you will write 7 plus with 3y over x. So no matter how you do, you can't separate it into two different means that y one side and x one side. So this type of equation that in the standard form, okay, if you look at this, the standard form here, if I refer to the standard form, which is dy dx plus with pxy equals to qx. Alright, so if you look at this, you have dy dx, right, standard, make sure here is 1, and this will be your px, this will be your px, and y to the power 1, so and qx, and this will be your qx. As long as you see this form of differential equation, the first order differential equation, this is called first order linear differential equation. Then you can apply the integrating factor here. So of course you don't know what is integrating factor yet. So but I teach you, okay, what is the step here. So you just stay focused and follow. Alright, the first step here is you must make it in a standard form. Okay, the second step is you must find the integrating factor. Alright, I said integrating factor. So we are represented by Vx, alright? The first step I go it slowly. So Vx is defined to be exponent integrate Px. Integrate Px. Px you can directly take from the standard equation here. So y, and this is your Px. Everything in front of y you are taken, include the negative. So I will put the negative here, negative 3 over x, right? Negative 3 over x, I taken out the negative. So then for now, you have to integrate this px here. So of course, you know that integrate 3 over x, it will be 3 ln x. Okay, for this case particular, we don't put modulus x because we're using this integrating factor here to help us to make sure that this can be solved into general solution. It's just a helper. This is just a helper, all right? So we have negative 3 ln x here. So as we know that we can bring the negative go up x to the power of negative 3, right? So you have negative 3 ln x. So negative 3 can bring forward as this is ln. And e and ln, you know that e ln fx, you can be written as fx by the logarithm law. So then you can retain x to the power of negative 3 or 1 over x to the power of 3. So clearly here is the integrating factor that I get is 1 over x cubed. This is the important, right? Very important. You have to get the integrating factor. To solve this type of differential equation, you must first get the integrating factor. Alright, let's move on to the third step. Alright, I will tell you the step, right, so that you know what to do. So the third step is I'm going to take this integrating factor, multiply into the standard form here. Alright, the equation that already in standard form means here dy dx. So you multiply, so you have 1 over x cubed dy dx. So minus with 1 over x cubed, 3 over xy, and 7 multiplied with 1 over x cubed. Can you see actually what am I doing? I am multiplying the integrating factor to each term, means multiply everything, both sides. Okay, you see the 1 over x cubed multiplied dy dx, the 1 over x cubed multiplied with this, and 1 over x cubed multiplied. Everything is multiplied with 1 over x cubed. The purpose of integrating factor is to make this integratable. So how is it? So I can combine this. Okay, without wasting time to simplify this, actually you can rewrite this whole thing in just one. This is the purpose of integrating factor, I have to tell you, is to rewrite this. After you multiply this integrating factor inside here, you can rewrite this in the form of one term. Alright, with here is a y, alright, y, and this is your integrating factor. You just take the integrating factor, put inside, just take the integrating factor, just put it inside, and just put a y here, right? And equate it to 7 over x cubed. So I want to tell you, so if you're interested, you can try. Let's say you apply this u and this is your v, means that d dx, this is operator for differentiate, right? So if you differentiate this one, 1 over x cubed, u v prime, this one will be your u v prime, alright, u v prime. So and is plus v u prime. So if you plus with v y, can you see the y here? So if you differentiate 1 over x cubed, you will get negative 3 over x to the power 4, right? Means this is the differential form of this function, alright? So means before I apply the product rule, this is the form. After I apply the product rule to differentiate this, I will getting this. So now I just want to rewrite this in this form here, all right? In this form, so that I can apply integrate both sides. So okay, very easy. Don't think so much. Just multiply the vx into the equation, and the fourth step, just write a d dx, put the y, and the integrating factor just put inside here. That's all. Don't think so much. So 7 over x cubed. So now the fifth step is you're going to integrate both sides. Integrate 1 over x cubed y with respect to dx. And you integrate 7 over x cubed with respect to dx. Alright? So means now I am integrating both sides. Can you see that? I'm adding this. I integrate this side and I integrate this side. So because suppose you want to differentiate this, right? You want to differentiate this, but at the same time you integrate this, so become nothing, right? So it become back to normal, so become y over x cubed, right? Y multiply 1, y over x cubed. So can you see that? So this differentiate and integrate become this. So finally, you integrate this side. You only integrate this side. So this side is rewrite as 7x to the power of negative 3 dx, basic form, right? So integrate this, you have 7x to the power of negative 3 plus 1. negative 2, right? Negative 3 plus 1, negative 2 over negative 2 plus c. Alright, so if I rearrange this, I will getting y over x cubed negative 7 over 2, 7 over 2, x to the power of negative 2 is x to the power of 2 plus c. Alright, but this one is easier, right? You can separate the y, you can write y in terms of x. If you see that this is very easier. So what I'm doing is I continue. Alright, I continue my working here. Okay, I rewrite here, sorry. So I just multiply everything with x cubed. I multiply with x cubed. So it means y equals to negative 7 over 2. X squared, imagine the x cubed is multiplied over here. X cubed over x squared. You will have negative 7x over 2 plus with cx cubed. So this will become your general solution, right? General solution for this first order linear differential equation. Y equals to negative 7 over 2x plus cx cubed. Alright? Okay. So in the following, I will give you more examples so that you know that this 5 step here, okay? You need to follow this 5 step. As after you're familiar, you will not need this step as you already used to it. Alright? How to do it. So let's look at the second example. Alright, let's continue with these examples. Alright, so you can try first. Okay, you can try first by refer to the first video. So okay, as you see that this is also a first order linear differential equation, so which can be rewrite in the form of okay, I repeat, it will be dy dx plus with pxy to the power of 1 qx. As long as you can write the differential equation, when you arrange, you can apply the way of solving the first order linear differential equation by using integrating factor. So by comparing comparing with this standard form here, so this is your px, right? You can recognize, you can know your px is actually 2 over x, right? The most important is your px. Alright, okay, so now your first step, okay, second question, let's say this is your first step. So your first step have to be in standard form, means that must follow exactly that. Okay, second step, you have to find your integrating factor. Okay, understood? This is your integrating factor. So the formula will be integrate dx, and this is your px, integrate px dx. Px, where to get the px? From here. So which is 2 over x. So easily, if you integrate 2 over x, you are getting exponent 2 ln x. Right? You are getting 2 ln x. As better we simplify this. As we know that e ln, and this can be rewrite as ln 2, bring forward x to the power of 2. And e ln, you know that there is a rule where you can write this into x to the power of 2. So clearly show that your Vx, I have already get my integrating factor. So which is x to the power of 2. Alright, this is your second step. Second step must correct. So means that the integrating factor must correct. If not correct, it won't help you in your integration later. So then the third step here, I'm going to multiply this x squared into the equation. So the third step is I'm going to multiply this into the equation. I'm getting x squared dy dx plus with 2 over x. Okay, this one easy to see. 2 over x multiply x squared. Alright, 2 over x means I'm going to multiply the x squared to each of the term. Alright, everything into equation. So 2 over x multiply x squared, I will have 2xy. And 2 over x multiply x squared, I get 2x, right? So and this one you're getting x squared over x minus 1. Alright, this is the third step where I already write multiply everything. Multiply x squared, I'm getting 2x, multiply x squared, right? So this is your third step. So your fourth step is this one important. Alright, this one important. So means that d dx, after you multiply the integrating factor into the equation, you straight away write d dx, one term, just now got plus, now become one term. So just put a y here, right? The y here. So what is this? What is this? This is your integrating factor. integrating factor. How to verify this is correct? Very easy. You look at this. If you apply UV, for those who are very efficient in differentiation, this is not a problem. You see, x squared u differentiate y dy dx plus v differentiate x squared 2x, right? Can you see? If you apply the product rule, you are getting back this. So now I just write this back into the original one, all right, before it differentiate. So it's equals to x to the power of 2 over x minus 1. Okay, this is very important. So after I getting this, right, the fifth step is I integrate both sides. The main purpose here of integrating factor is to help you write into product form, okay, into this form, this differentiate form with this operator, so that I can integrate both sides, right? So I can integrate both sides, x squared y dx, integrate x squared over x minus 1 dx, right? Can you see the difference between these two? d dx x squared y, x squared over x minus, I just add integrate dx, integrate with respect to dx, integrating both sides, right? Integrating both sides. So differentiate and integrate at the same time. So I will getting x squared y, right? I will x squared y, so means I get to back to the original equation. So then I have to integrate x to the power of 2 over x minus 1 dx. So this is our purpose here. Alright, so now, of course, after this is your integration skill, right? So for these cases here, and this is an improper fraction, we're going to apply long division, right? As I teach you before, x squared, right? X squared plus 0x plus 0, I just add this way, it's a quadratic, so divided by x minus 1, so I have x squared negative x, then I do long division, right? Do long division, x squared negative x, so x squared minus x squared, and you get positive x, right? You get positive x. You get positive x here because 0x plus you get x, and you bring down the 0 plus 0, right? So plus with 1, why? Because 1 multiply x minus 1, right? 1 multiply x, negative 1. So after you deduct x minus x, you have 0, right? You have 0, and you have 1 as your remainder, right? So 1 as your remainder. So finally, before you integrate, so it's better for you write in the proper fraction, which is the quotient plus with the remainder over with x minus 1 dx, right? I have rewrite this into a proper fraction. So as you multiply, you get x squared minus 1, x squared minus 1 plus 1, you're getting x squared over x minus 1. If you combine, you are getting back this. So now I integrate. So x squared, right? So I'm getting x squared y, integrating x squared over 2, right? Integrating 1, I get x. Integrate 1 over x minus 1, easy. Ln modulus x minus 1 plus c. I have done, right? I have done. So, but because of this, compared to separable variable, which is much harder to separate the y and x, but this one easier. You can write y in terms of x. So why don't you just simplify further, right? So, so you can divide everything by x to the power of 2, right? Divided by x to the power of 2, you are getting 1 over 2. X divided by x to the power of 2, you're getting 1 over x. And 1 ln modulus x minus 1 over with x over 2, x power 2 plus with c over x to the power 2. Alright, so this will be your general solution for this first order linear differential equation after apply the integrating factor. Alright, so for this video, I have introduced you how to apply the integrating factors and what's the step that you should take so that you can get the general solution. So let's move on for the next video for more examples about first order linear differential equation.